Good afternoon, everybody. Actually, I will start from where my colleague Dr. Aday finished. I will try to introduce you in brief to our work during the last year. The title of my presentation is Reverse Engineering of Historical Mortar and Plaster to be used as eco-friendly in construction materials. Our research team are Dr. Aday Saeed, of course, and engineer Naila Dawood, and also Dr. Riham Mqdadi and engineer Kamal Rinat. Actually, different natural and human factors have caused rapid degradation in architectural heritage, as well as some conservation and restorations projects which have negative impact in some conservation and archaeological values because of applying incorrect materials and incorrect techniques during the conservation and restoration process. Therefore, this project focuses on reverse engineering of historical mortar and plaster to be used as eco-friendly construction materials in green buildings and conservation applications. We can, actually there are two major types of mortar. The first one, the lime-based mortar, which can be considered as one of the oldest known types of mortar, dating back to 4th century and widely used in ancient Rome and Greece. The second type of mortar is the gypsum-based mortar, which was common to ancient Egyptian construction. Also, we have two types of plaster, the lime-based plaster and the gypsum-based plaster. The objectives of our project is to study the composition of original mortars and plasters to reconstruct their recipes. Second, to develop duplicate mortars and to validate their applicability in the laboratory and on-site tests. Third, to establish standard specifications for mortar of each site. Finally, to establish a permanent conservation team and train workers group from the local community on the traditional techniques of mortar and plaster. Around 30 samples of mortar and plaster were collected from different sites, different historical sites in Jordan. The first site was from At-Tuba Palace, which is one of the Umayyad desert palaces in Jordan. In this photo, we can see the mortar, which is still in good condition after more than 1,200 years. In this photo, we can release that there is nice merging between different construction materials, such as natural limestone in the lower part of the walls and the fired bricks in the upper part of the walls, as well as two types of mortar, the gypsum-based mortar in the upper part, and in the lower part of this wall they used the lime-based mortar. This photo can show us the width of the wall, which is around 1.6 meters. Also, some samples of plaster were collected from shaft cistern. We were lucky actually to find two layers of plaster in this pool, The inner, we collect the inner layer of a plaster and the outer layer of a plaster. Plus, we collected some plaster samples from Mar Elias Church and from Ajlon Castle also. Here I would like to point out that there is no direct approach to make reverse engineering for the mortar or the plaster. Therefore, we followed different and various scientific approaches to achieve at the end a clear image of the recipe which was used during the Roman era or during the Islamic era. The first scientific approach were producing petrographic study for most of the mortar and the plaster samples and study it under polarized microscope. In this photo, I can easily distinguish some agglomerates, some fragments, which we can call it aggregates, from limestone aggregates, and the cement material, which is lime-based cement material, sorry. And in the next picture, figure number 2, we can distinguish the fly ash. Sorry, there is no pointer, so I find it difficult to. Okay, in figure number 2, it's easy to see the plant ash. And in figure number 3, the red color represents the crushed fire bricks. Okay. The second scientific approach, we use the XRD mineralogy study to determine the mineral content also. So in figure 1, XRD bottom, which represent the mineral content of calcium carbonate and quartz. And in figure 2, it's mortar sample from Atuba Palace. And actually it's gypsum. G stands for gypsum actually. So it's gypsum based mortar. And the other content are the quartz and the calcium carbonate. The third scientific approach which we used is the crushing the sample and make picking crystal by crystal under the optical microscope. And actually this table took from us around 1 month of work. Actually it was hard work. So the result of the, as example, the outer layer of plaster from Shash cistern, around 46% grock and around 90% aggregates, limestone aggregates and chert aggregates, and the cement material was lime around 35%, and charcoal or plant ash around 0.2%, and the rest is quartz. The fourth scientific approach is the chemical analysis for the mortar and plaster samples, and based on the previous analysis or scientific approaches and the chemical analysis, we can make like reverse engineering for the original mortar and plaster recipe by make material balance calculation. The expected outcome of this project to establish standard specification for mortar and plaster for each site, for each historical site in Jordan, and the durability and improving the efficiency of repairing mortars in the architectural heritage, finally establishing a full trained restoration team group. Conclusion and outlook. This table represents the proposed mixes from various materials estimated from the chemical analysis of total elements using the material balance calculation. And finally, all the proposed blends or mixtures will be evaluated for mortar and plaster, will be done based on previous literature such as Putgar's 1997 and Knopfel and Hosman 1993 and Umari 2009 to make a comparison between our results and this standards, because until now we don't have standard specification for the ancient mortars and plasters. Thank you for your attention.